this lecture notebook, for web scraping, we use the Pandas library, and particularly the read HTML command, to create lists of data frame objects that contain the various data presented in tables on web pages. There are other resources that you can use for web scraping, and I describe some above here that you can read through. I really recommend it. I also recommend clicking on some of these links involving Pandas, which is a very impressive module that you may want to become intimately familiar with if you ever do any serious data analysis. The name Pandas is derived from the econometrics term panel data, sometimes referred to as longitudinal data by statisticians, that describes multidimensional data involving measurements over time. I highly recommend taking just 3 to 5 minutes and reading the full overview of Pandas. It's really short. You can just read it right here. It's not that long to just scroll through and read what's going on here, what is Pandas, the community, the whole thing about the project. Just take a few minutes for that. I also recommend the 10-minute introductory tutorial that describes Pandas. You'll see it's very similar to NumPy, whereas in NumPy, we use arrays as kind of the typical data type, the array data type, as a typical object for us to construct and analyze data. In Pandas, it's a data frame. So there's similarities, but there's also distinction. There's some difference between what these things are, these data frame objects versus these NumPy array objects. So that's what we're going to be using, and we're going to get started in just a second. Here we are going to see how easy it is to use the read HTML function within the Pandas library. We're going to practice using this by reading in roster data from the Denver Broncos official website. First, we're going to import Pandas as PD. Then we are going to define a string variable. So first it's got to connect to the runtime. Let's just take a second so it'll connect to that. And while it's doing that, I also want to point out that we will create a string variable that holds the web address for the Denver Broncos roster. So, all right, I'm connected to the runtime. I've imported Pandas as PD. I have this URL, which is obtained by just going to the website, copy and pasting this URL at the top in between 2 tick marks to create a string variable for the URL. And then all I do is feed that URL into the read HTML function of Pandas. And then I read in all the data that it can from that website that's in a table format. It tries to read in that data, and every individual table gets read in as its own data frame in a list of data frames. So even if there's just one table, it will create a list with a single component. So I'll just go ahead and show you this here. If I create this list of data frames, if I actually look at the type of the variable that was created, you'll see that it's a list. And if I look at the first component of it, you'll see that that is a data frame. So there you go. How many data frames did it create? That's what the next piece of code does, and you see it created 3. Why did it create 3 data frames? Well, if you look at this website, you'll see that there's this active roster. And if we scroll down a bit from this table, you'll see that there's another table that contains the reserved and injured players on their roster. And if you scroll down a little bit more, you'll see that there's this practice squad part of the roster as well. And then you'll see that there's no other table data here. So there were 3 tables. Each of those tables were imported and stored as a data frame. Now you say, oh, well, I want to maybe use the print command to view the information in an individual data frame, let's say the active roster. And if you look at it, you kind of go, oh, that doesn't look so great. You can kind of scroll through this, but that's not in a format that looks very nice. If we scroll down to the next code cell and you just don't use the print command, and I just say, I just want to see that first active roster data frame. If you do this, it's actually a much nicer format. So here, I'll just kind of scroll up again, and you'll see this is how this is all displayed. This is a much more visually appealing way to look at the data. And if you click on this little icon right here, you can convert this data frame to an interactive table. This is a nice feature of Colab. If you click on that, then you'll see that this looks kind of like an Excel sheet now in terms of the style, and you have the structure. It's just a little bit nicer than what we were just seeing. You can try to copy this table and paste it into let's say into an email or some other content if you're wanting to share it. You can also say I want to show more of the entries instead of just maybe 24. Why is it 24 there? It says 25 per page. Again, indexing starts at 0. But let's say you went down to 100, then you have the whole active roster. because it goes to, there's 52, I guess, players on their active roster currently. So it's at least when I'm making this video. You can even then click on the filter button, and you could close this at any time, but just with that X over here, that will close the filter. But with the filter, then you can actually filter information. You could specify a specific height. Maybe I want to see all the players that are 6'5", and if I do that, then here are all the players on the roster that are 6'5". Maybe I want to look at players that are, let's say, above 250 pounds. And then you'll see here's the players above 250 pounds. And maybe then you can specify experience. You could specify age. Maybe I want to see all the players that are over 30. And so you say, okay, there's all the veterans, definitely they have a lot of experience. Maybe I only want to view the players that are up to age 25. And, I scrolled up. I didn't know what happened for a second. There you go. It's all the players up to age 25. So now that's shown. And you can specify a range as well, like 20 to 25. And that'd be the same thing. Because I don't think there's any players younger than 20, but maybe I go like 23 to 25. There we go. So that's a little bit different because I think they had some 22-year-olds in there, if I recall. Yep, there's a 22-year-old right there. That's a rookie. So that's a way you could filter data and kind of play around and get some initial idea of what's going on in the data, and just start doing some filtering and some basic initial qualitative exploratory data analysis just on what's going on in a data frame. Now, you'll probably get tired of just working with the list of data, and you want the list of the data frames. And so one thing you could do, if you know which of the data frames you're going to work with, is you can read in the HTML and you can specify, just like we've done this before with indexing with slicing on arrays, is I could say, well, okay, I just want the first component because that's the active roster. So then this could create this data frame for the Broncos that I just have the variable name df_Broncos. You could also, because you've already created this list, just assign that to df_Broncos, and then I wouldn't have to type, I wouldn't have to use the 0 anymore. But I'm just going to show you can do this exactly on the read HTML, which is similar to things we saw in computational applications, where a function can return an indexable object, an iterable object, and you can just say, well, which of the components do I actually want? And so this is just saying return the first data frame. If I know the first data frame is the one I really want to work with, which for the purposes of this video it is, then I would run this, and then I would only get the data frame for the associated with the Broncos active roster, which you can see right here. So there you go, you can scroll through. And again, you can filter this and go through all the things I was just showing you with filtering. So one of the nice commands with the data frame is you could say, I just want to see like head. And this is just going to show you the first 5 rows of data. Just as soon as you create a data frame, maybe you just want to see the first 5 rows just for a quick view. You can feed the head command, again, .head for the data frame, because it's an object that has methods associated with it. It's instantiated from a class. And in that method, you can specify the number of rows, the first rows you want to see. So this will say the first 10 rows. So there you go, there's the first 10 rows. I can look at the shape. This will tell me how many rows and columns there are in the data frame. So it's kind of similar, again, to a NumPy array, except within this data frame, every single one of the columns has a different type of data in it, whereas a NumPy array, all of the array has to be the same data type. You can use iLoc. So what is that? I would say iLocation. This is an indexed location. That's what the I is for. And so if I say 0, comma, with now this colon, this is going to view all data related to the first row. So this is kind of like array slicing. It's data frame slicing, and I'm using the index. So I could say, okay, view all the data in the first row. And if you look at it, you kind of go, why is it formatted like this when up here this looks so much nicer? Okay, if you want to view it in a nicer format, what you do is you give it as a list. In that iLocation, give the rows that you're interested in as a list. So here it's just 0, and that's the first row. And so there you go. I see that Calvin Anderson. This is based on when I'm running this. When you're running it, the roster might change. But imagine I said I want the first and the last row. So I just have this list, and I do 0, and I do negative indexing. Let's say -1, and then there you go. There's the first row and the last row. So Calvin Anderson and Russell Wilson are the first and the last rows in there. And you could put whatever you want, but if you make it as a list there, then it will just display nice. That's the only point that I'm trying to make with that. So, okay, I'll just rerun that. If I want to view the last rows of the data, let's say the last 5 rows, you can just do simple types of array slicing type notation like we're using here, again with this indexed location, iloc, that's very important. So -5 colon, and that will view the last 5 rows of the data. So again, there you go. There's the last 5 rows of the data. The iloc is expecting integer inputs for its indexing. So I can say, well, iloc, and let's say I do the last 5 rows, but maybe all I want to look at are the names. So that's this player, that's the first column. I want to maybe look at the height. So I look at this and I go, okay, if that's the first column and I want to give it numbers, and this is the iloc, so it's expecting integer inputs for indexing, then I would have to say, okay, the first column is index 0. Then their uniform number is this next column. Then the position that they play is this third column. The height is the fourth column. Python indexing 0. So if I want the player height and player name, height, and weight, I'm going to have to give it 0, 3, and 4 as a list in order to just view that data. So this is just kind of a subset of the data frame, but it allows me to just remove maybe data I don't care about. Maybe I don't really care what their uniform number is. I just want to look at the player names, their heights, and their weights. I don't maybe care about what their positions are, where they went to college, or whatever. So again, then you can just go ahead and convert that data frame to an interactive table. Whenever it's in this nice format, you can convert it to an interactive table. Now there's this loc command, not iloc, that allows for a mixture of integers and features, but it is label based. What does this mean? Negative values are not present in the index labels, so you got to keep this in mind. Running the code below will be interpreted as asking for all rows starting at -5 and onward, which is fundamentally different than starting at the 5th row from the end. So let's say I run this. I say, okay, I want to do this location, and I'm going to say -5 to there. So player height and weight. So there you go. Like it's everything. You know, look at this. This is all the height and weight data because -5. This is not iloc. There is no negative integers there. So it's basically saying, oh, well, start at rows starting at -5 and moving onward. Well, 0 is certainly onward, let's say, from -5. So it's just going to show everything. So what happens if you give it a number that's beyond that? So here, let's say I do 74. I think I had this because at one point it was a bigger roster when I ran this with preseason data. But I run this, there's nobody there, right? There's nothing starting at 74. So if I actually want to use the location to print the last 5, let's say I have to go to 51 -5 here. So let's go like 40. Let's see if we do. I think it's, yeah, 46. There we go. I think I started with it 47. Let's go 47. There we go. Then it's 47, 48, 49, 50, 51. Depending on how many players are on the active roster, you would have to adjust this this number. So this is going to depend on that. When I was originally doing it, it was with the preseason, and so then there was a lot more people on the active roster. So at this point, I would say pause the video, play with the things I was just showing you, and also try it out for yourself. So this is a suggested activity. Create some code cells below to explore differences between the loc and the iloc to print out some specific rows and columns of data from this data frame. So go ahead and I would say pause the video, give this a shot. So one of the nice things about data frames is that there's a way that they allow you to do some very simple visual inspection of data by adding some style to the data frame. So one of the things you can do is say, I want to stylize, basically take the data frame, do .style, and what I'm going to do here is say .bar, and then I'm going to give it a subset of features here, and I'm going to use age and weight data. So these are the names of the columns that are associated with the age and the weight. And so if I go ahead and just run this and look at it, it creates bar graphs on the data where I have the lower values are associated with the lower numbers of that numeric data, and then the higher values of the bar, the bigger the bar is associated with the larger values. So this is a way for you to add some initial visual elements so that you could scroll through the data and initially see like who are the oldest players and the youngest players, the heaviest players, the lightest players. So you could just scroll through and say, oh, that's exactly how I can visualize this very quickly. There's some other things you can add as well, like maybe you could add a different type of background gradient. So here I'm doing this to the subset of weight. So again, I'll run that. And so this is also similar. So let me just scroll up a little bit. There we go. So now the darker colors, excuse me, are associated with the heavier players, and the lighter colors are associated with the lighter players. So pretty simple ways to stylize your data frame, add some visual elements so that you can quickly get some visual information about the structure of the data and the distribution of values in certain numerical categories of data. So what we just saw there was some built-in style features that are within Pandas, but we can even define our own using user-defined functions. So maybe I want to highlight players that are greater than 300 pounds. And so the way you can do that is create a function. I just defined it here, and I'm going to give it S, meaning this is basically the data series that we have within a particular column. And I'm going to look at the weight, right? So it's expecting this weight attribute. That's the one that I'm expecting that the data that I'm passing it, this data frame, has a weight feature. And I'm going to look if that weight feature is greater than or equal to 300. If it is, I'm going to return that the background color should be yellow and it should be applied across all the columns. Otherwise, I want to make the background color black across all the columns. Then within my style, I can apply my custom function, and I can do it across axis 1, which would again be all the columns. So when I run this, one of the things that you'll see is this is exactly right. You can see that I'm highlighting in yellow all the players that are above 300 pounds. This is generally offensive and defensive linemen. And then the other players are highlighted in black. So this is a good way to kind of create a nice filter. You could, again, with these data frames, you could just filter the data if you have this interactive table, but outside of Colab, you don't necessarily have that feature. And so this is a nice one where you can kind of have all the data and you can provide some custom visualization to filters of data, and you can kind of filter it however you want. I did it here on weight. I could also do it based on positions, like maybe I want to highlight all the wide receivers. And so then that's based on the position of the data, the position that they play. And then I do the same thing. If it's a wide receiver, make it yellow, otherwise make it black. And so you can see it did it here. All the wide receivers are in yellow and every other position player is in black. So they don't have a lot of wide receivers on their roster, and that might be why their passing attack is so terrible this year. So try it out for yourself. This is again a suggested activity. Use the code cell below and any others you want to create. Highlight all the linebackers on the roster. There are 3 types on the roster. And a linebacker is just a general linebacker. So an LB is just a general linebacker. An OLB is an outside linebacker. And an ILB is an inside linebacker. If you are clever about using slicing, you can avoid using logical or in the function. But go ahead and give that a try. Try to do this. You could use if, else. There's other ways you could do this. So you could also use ORs in here in terms of your user-defined function. But try to define some highlighting for linebackers, where if it's any type of linebacker, you could apply it in yellow. Just try to figure it out. See if you can do it for yourself. We now go over some useful built-in methods within Pandas to manipulate or interrogate data frame objects. So the first thing I'm going to do is I'm going to look at what the column names are. So I'm just going to go ahead and run this code cell, and you'll see that I have the column names as player, their uniform number, POS for position, the height, the weight, age, and so on. But you see what the names are. And you'll see that this is a, what type is this? This is a core index based, it's based on index. That's what it is. It's just a way of indexing. So if I look at the data types of each of these objects, here's one of the things you'll notice. The player type is an object. Okay, the number is an integer, that made sense. The weight is an integer, the age is an integer. Everything else is object type. So that's a little interesting, right? Because some of these things looked like numbers, but they were object types. So let's look at this. Let's look at the player. So if we just look at from this data frame, if you just do the dot convention with a column name, right? So again, these are the column names. Then you'll just go ahead and get the series, this data series that includes all of this information. So what is this? which is saying that it's a series. So a data frame is composed of these data series. Each column is a series. If I look at, let's say, the different data series, and I say, well, compute the mean across the entire data frame, what this will do is this will produce a mean of all the numerical data in this data frame. Well, we see that there's only the number, which is weird. Like, what's the average uniform number? That's not a meaningful statistic. But then there's the age and the weight. So I can get the average age and the average weight. Those are meaningful statistics to compute. And I can say the average uniform number, that is meaningless, but the average weight is 242 pounds, just about, and the average age is about 26 and a half years. Of course, this will vary over time as the roster changes, so it depends on when you watch this video and work along in this notebook. But that's what we have. But you can also specify a specific column to compute a statistic. So if you just do .mean, it will look through all the series data. It will look for which ones have data types of numbers that it can actually compute statistics on, and it will compute those statistics. And then, of course, like the average value will generally be a float. Well, I can say, well, what about the weight, right? If I only want the weight data, I can just specify .weight and then .mean. And it's a function, it's a method, so I have to have those parentheses. And you say, okay, there's that mean value. You say, well, what about the height, right? The height looks like numerical data, but it's not, right? I get an error. I get value errors all over the place. And it's saying, what's going on? Well, this is malformed. This is a malformed string, and it's saying this is a type error. You could not convert, right? So there's a couple errors here. You see a value error and you see a type error. What's going on? What's the deal with this data? The deal is it is given as a string to represent units of feet followed by inches. If you actually look at an individual height data, like if I look at the first one, I look at its type, it's definitely a string. And so the first player that happened to be when I created this data set, when I read it in from their roster, is 6 foot 5 inches. And that looks like 6-5. But that's a string. That is a string variable. And so one of the things you can do is I could take the height data and I could use this command that's a part of strings. I could do .split, and I could split the data on either side of where that dash is. So now when I print that data, you see, oh, I now have a list returned from such an operation with .split. And I have 6 as a string and 5 as a string. Okay, so what if we used, let's say, a list comprehension? And I'm not usually this slick, but I just couldn't resist showing you something here that involves list comprehensions because we've done these before earlier in the class. I could take the height data that I want, or to convert it to a number. I could convert it to numerical values. So I could take, since they're integer types, I could cast this as integers. I could cast them as floats too, but they're integers, so I'll go ahead and cast them as integers. So I could look at for the data. So this is in a list. I'm going to take and cast as an integer the data for the data that is in this list of strings returned by splitting the height data on either side of that hyphen. If I do that, then you see the 6 and the 5, and notice there's no tick marks there on either side of the numbers. So this is now integer type. So what does that mean? Well, that means that I can go ahead and create a basically list of lists. That's what I'm going to do here. I'm going to create a list of lists, and I'm going to do this casting into data for data in this for this height data that's split across the hyphen. But I'm going to do it for each of the I rows where I is taken to range in the length of the series of height data. So there's kind of a lot of things going on inside that one line of code. But if you see what I'm doing, the end result is I created a list of lists where each component of my list is a list containing the height and feet of the particular player associated with that index in the list. So the first player happened to be 6'5", the second player happened to be 6'6", the third player happened to be 5'10" at the time when I created this video. Now that they're integers, I can transform that into inches. So the height data in inches, I could take, here's another list comprehension, I could say 12 times the first component of my data plus the second component. So the first component is in feet, the second component is in inches, right? This is 6'5" inches right there. So I want to multiply, if I want to create this in inches, take that first component, multiply it by 12, just add it to the second component because it's already in inches, and I'll do that for every single one of these data values stored in the list in my height data list of list. That's what I'm doing here. So finally, if I run that, you say, oh, now I have a list where all the height are in integers. Okay, that was slick. It required list comprehensions, and it might have seemed a little confusing. It might have been hard to follow, and I wouldn't blame you if you said that's not something I want to do. The use of two list comprehensions above, the way I was doing it, was completely arbitrary. We could have created a user-defined function to do the same thing, and I'm going to show you this below. You should add comments to this function to make sure you understand all the lines of code. List comprehensions are pretty slick. They do not necessarily make for the most readable code except the seasoned Python programmers. So this is me speaking. Not, other people may disagree. But if you followed all of this, great. You're coming a long way in your understanding of Python. But I think a lot of people would have trouble understanding all these steps because there's a lot of knowledge crammed into individual lines of code. I think it's best to opt for clarity over cleverness in code that you're creating. I usually opt for writing code that is as straightforward and as easy to read and understand on a line-by-line basis as I can manage. So I'm going to create a function that I define as xform. So I use xform as an abbreviation for transform. So I want to transform the Bronco's height to inches. I'm going to assume that I'm getting height data. I'm going to create, so I'm going to assume that this is coming as a data series, as a Panda data series. And I'm going to create an empty list. And then for each I in the range of the length of my height data, so this would be for all the height data that I have, I'm going to create that data that is based on splitting this height data that's in string format on either side of that hyphen. So then I'm gonna have this is a list that has the height in feet as the first component and inches as the second component. I'm then going to cast each of the components as an integer. I'm going to multiply that first component of that list by 12 to turn it into inches, and then add the second one. These are comments that you should add to the code as well. Because I created an empty list, I then use the append method to the list to then basically row by row create this list of inch data. But I like this because I think it makes sense like what every single line is doing, whereas an individual line of code here is doing multiple steps at once above when I did these list comprehensions. So with that user-defined function, I don't know what just came. Oh, I think I was pressing the key too many times. That was a little weird. Sorry about that. Now I have this user-defined function, and now I'm going to create this height data inches redux. So this, I'm going to create my transformation of Bronco's height data to inches. This is this user-defined function I have. I'm going to feed it that data series that comes from the data frame, just that column of height data. And I'm going to show you this creates the same list of data that we saw here, but I'm not doing it with list comprehensions. I'm doing it with this user-defined function. If you need to pause this video, rewind it, rewatch that part, please do. This might take a little while to understand, but the main point that I want to get across is I think creating your own user-defined function is a clearer way to move forward in transforming the data. Now, you can also do this with slicing. I do something here, so because we know the structure of data. I'm just showing you there's more ways to do things. This is something else. Maybe you want to do it this way. What is the point of all these last few code cells, all the things I'm showing here? There are lots of ways we can go about manipulating the data to get it into a format we want. Here we'd want to convert the height data to numerical format because then we can actually compute statistics about it. But which way should you do it? Which way is best? There is no best. You just use the method that makes sense to you. If you can find a quick, easy way to do something with list comprehensions, then great, do that. Just do it. If you don't see how to do that, if you're not comfortable with list comprehensions, fine. Try a user-defined function that formats things how you want. Does the data have regular or predictable or repeating structures to it that allows you to use array slicing techniques or other methods you've learned? Or does it have some type of string character or characters that you need to get rid of by using split commands or some other way of removing them? Maybe the answer to all of these questions is yes. Maybe some of them are yes, some of them are no. The point is you're going to have a lot of options, and you're going to have to make sense of what makes sense to you. What is the way you want to go forward and solve the problem? And you're just going to have to examine and think about what the format of the data is in versus what the format of the data is that you want it to be in. And that's going to be key to how you choose how to manipulate it. And once you've done that and you've transformed the data, I can take and overwrite in the data frame. I can take that height data that was in that string format and I can put this array of inch data that's in integer format. And again, you could have made it floats. You could have cast it as floats. But now if you look at this, I want to scroll up. When I look at this height data now, you don't see 6'6", you see 77 inch, or I think 6'5". 6'5", you don't see 6'5", you see 77 inches. You don't see 6'6", you see 78. So these are inches now. Now, it would be good when you start changing that, maybe you want to rename the columns. So I can rename, I can say, okay, go to my data frame, and I want to rename a feature. What do I want to rename? Which column? I'm going to pass it a dictionary. And the dictionary that it's going to contain on the left, the feature I want to rename, which is HT for height. And I want to make it height in inches. And I want to make this, I want to do this in place. What does that mean? It means we change the actual data frame variable. So you could try making that false and see what happens. But I'm going to leave it as true, and then I'm going to show you when I rerun this data frame, just to do the output, I have actually renamed the column height in inches. Now when somebody sees that, they know exactly what that means. Okay, 77, that's in inches. 78, that's in inches. So now it makes sense. And so now, excuse me, if I actually look at this data frame dot height in inches, it's not dot ht anymore, it's dot ht in inches. You see there it is in that numerical format, and it's of type integer. And now if I say compute the mean on the data frame, now it actually returns the mean height, 74. So about 6'2", that seems to be the average height at this point in time when I created this data set. So again, you might want to pause the video here, run through these things yourself, play around with the code, add your own comments, add your own code cells where you're trying this and reformatting. Maybe you don't want it to be in inches, maybe you want it to be in feet as a float because you have fractional feet here as opposed to integer integer in inches. So, and you can imagine maybe they report that somebody's like 5.5 inches, but they seem to be reporting it in whole inches there. Anyway, play around with it. Pause the video. It's going to require you to do some things to get familiar with it in order to get comfortable in playing around with data frames and manipulating data so that you can change some data that might look numerical into an actual numerical format so that you can compute some simple statistics like mean values. What about cleaning up other types of data to be more amenable to statistical analyses? Because sometimes data is missing. Age data sometimes is not available, or it can be incongruent with the form of other types of data. For example, in the above data set, experience is listed as EXP as the feature name, the column name, is given in years except for rookies that are denoted with an R instead of a 0 for their years of experience. If you wanted to compute statistics relating to the experience of players on a roster, for example, to try and quantify the collective NFL wisdom of the roster, this is immediately problematic, as we will see. So if I import NumPy as NP, and let's say I look at where the index where the Broncos have rookies. So I can say, okay, I will use the np.where command to find all the indices, and I just want to say return the first result from the np.where command. That's all I'm doing there. This is going to tell me all the indices where the experience series is equal to the R string. So because this is a comparison, I want to find where they're equal. I use two equals and not a single equal. So then I can print all these indices. So now one of the things you can see is, okay, there's several places where they have rookies on their active roster. And if I don't write zeros to them, so I'm just going to go ahead and show this. Well, we've seen it already, actually, so I'm going to show this here. When we look at this data, when we look at this roster data, we see these numbers, but we also see these R's. So we know that there's this data type here that cannot be integers for all the data in this column of experience, this EXP value. And when we were computing the mean of the data frame, we didn't see the experience listed anywhere. So we know it's not numerical data. And you say, okay, well, what happens if I change all the experience to 0? Okay, or excuse me, all the not all the experience, although they're certainly playing like all of their experience is 0. But if I change where every place where it's listed as an R, it's now equal to 0. Does this allow me to compute the mean? No, it doesn't. We still see that only the height, the weight, the age, and the player uniform number, which is irrelevant, are the types of data that we can compute statistics of. So what's going on? What's the average experience? We still aren't able to compute it. The problem is the data type is not what you think it is for the other entries, even though they look like numbers. If you look at, for instance, the first component of this data, which wasn't a rookie, so it didn't have a 0 there, you actually see it's a string, right? You see the quote, the little tick marks on either side of the 4, that's a string type. So we have this mixing of ints with strings now because we did make this equal to a 0 as an integer. So for all the rookie locations. So if I actually look at where the first rookie is located, that index, and I say, okay, what data point is that? You see 0 without the tick mark. So we see, okay, I have a mix of integers with non-integer types. Well, guess what? Just like with NumPy, where we can use the as type, we can use as type on this series data type within the data frame, and we can rewrite the experience as the experience cast as an integer type for all the data. And if we do that and we look at, let's say, that first entry again, we see that 4 without the tick marks, and now we can compute the mean, and there you see the average experience is about 4 years, although they're certainly playing like they're all rookies this year when I'm making this video in 2022. In case anyone's wondering, when did Troy make this video? I made it when they sucked, the first year of Russell Wilson. I hope I was a big Russell Wilson fan. I still am. I'm hopeful, but yeah, they're playing pretty bad this year. So that's kind of it for this first part of the video. There's some activities that are coming up, but I think this is a good place to pause the video, play around with this as well. You might look at casting types as, different types. You can cast it as a float, see what happens. But again, play around with things. Try doing your own web scraping in data from other teams. That's a good thing to do, and see if you can kind of go through these steps for yourself and play around and transform the data. So that's it. I will go over this first activity in the next part of the video. So in this first activity, we're go Nuggets go. We want to read in the Nuggets team roster data from ESPN. So I went ahead and put a link there. So you can see there's a table of data here. It should be able to read it in. And you see that we have these pictures. That seems to be part of the data. We have the names, we have the position, the age, the height. You can see it's in a different format. It's not like 6-6. It's 6 feet 6 inches with these tick marks. So that's going to be some interesting thing that we're going to have to grapple with if we want to convert this to integer or float types in order to compute statistics. The weight, they have these units on the weight as well. So these are definitely going to be string types. We have colleges, but we also have missing data. We have salaries, we have these dollar signs. So that's going to mean that these are string types. We have missing data there. There's some interesting things that we're going to have to grapple with in order to compute statistics. So there's a couple entries I see where there's missing data in the college and the salary at the point in time when we're going through this video. So that's what the data looks like. That's what we're going to read in. What I'm asking you to do is transform the salary into floats and change the label into salary in US dollars, salary underscore in, salary underscore USD. So I want you to remove the units. And also another thing is you want to remove this dollar sign. You also have these commas that are kind of messing you up. So you might want to use the split command. You might want to use some array indexing to just say, I want to take everything to the right of the dollar sign by just indexing the string, and then also splitting stuff or just removing the structure around with these commas. So that's something you're going to have to figure out how to do that, although I will have the solutions showing as well. And then I want you to change the missing college data into a string in /a. So there should be tick marks on the other side of that, so that it's a string variable. And then here's a question. Why do you think maybe it's unimportant information, maybe it's not, depends on your perspective on whether or not players went to college, but why do you think such data or information is missing? Why is maybe some salary data missing? For instance, if there's missing salary data, I want you to transform it into not a number. Why do you think such data might be missing? These are good questions because when you actually do real data analysis, real data is messy. There's often missing values, and you should ask yourself why. Why are there missing values, and how do you want to deal with those missing values? I also want you to then change the weight and the height into floats, not ints. And I want you to relabel those columns as weight underscore pounds so that the idea of the units is in the column name, the feature name, and the height underscore inches, HT underscore inches. So that, again, that's in that name of the label. And then I want you to compute some statistics on certain columns and comment on the results. So that's what I want you to do. So it's basically kind of like what we were doing for the Broncos roster data, except you already see the structure of this data and information we have is different than what we saw for the Broncos. So you can base results based on what we've seen. You can start with the types of functions and manipulations that I showed you above, but you're going to have to tune them to the type of data frame you're going to get here. So this is a great place to pause, really try some of these steps on your own. And then even as I show the solution, try to just watch as much as you need to if you're getting stuck on your own way of solving this problem, and then watch how I solve it only as far as you need to in order to try to get to the next steps. The more you kind of can struggle with it a little bit on your own and really figure it out, the better. With that, I'm going to take a brief break. I'll be right back with the solutions. I now show the partial solutions for this first activity. In particular, I'll show you how to change the salary into US dollars, where we transform all the data that we have available into floats, and we will change any missing salary data into not numbers. I'm not actually going to change this in the data frame. I'm going to leave that for you to do, to change all of this in the actual data frame, which you should be able to do by following what was done in the first part of this video above with the Denver Broncos roster data, where we actually are writing this into the data frame. I'm also going to show you how to change the height data into inches, because that's a little bit more complicated. But the weight data I'm going to leave for you to change, and also the missing college data. And again, then you need to go ahead and change this in the actual data frame. I'm not doing that part, and changing the labels of the columns, and then computing statistics and commenting. So you still need to do those parts. I'm going to do the harder parts here for you to help you out. So the first thing is use the URL for the Denver Nuggets roster. And when I create that string variable for that URL and I use the read HTML to create a list of data frames, it ends up creating a list of a single data frame. There's one data frame. So I'm just going to go ahead and redefine that one data frame as nuggets. And then we can see this is what this data looks like. What's going on with this first column where you see it's all this not numbers? That's actually where the picture was, their little profile picture that was part of the data. When you click on this link for their roster data and you look on this left-hand side, you see the pictures of the players. So that's read in as just not a number. It doesn't know how to read that in. There's also this interesting thing here where their names have their player numbers attached to the end. So that's something else that might be worth cleaning up. That's a good extra suggested part of this activity I recommend, is go through the names and clean up the numbers, remove any numbers from the end of the name there. So again, why is that there? If you look at this link, so I'll go back here again and click on this link, you see that their name's there and also their uniform number. What number do they have that they're playing under? So that's just, they put that as part of their name for some reason. And that's just a weird thing with how that data is structured in this website. So then we have their positions, the age, the height, the weight, college, and salary. Now I'm going to go ahead and take the salaries and just read that off as its own series. So I just read off all the salary data, because again, salary is the name of this feature, this column, this last column. And so here's what all the salaries look like. And you see there's the dollar signs, there's the commas. So if I actually look at that, I say, well, that dollar sign is the first component of every single one of these values, wherever it happens to appear. Sometimes there's no salary data at all. And again, I ask you to consider and to comment, like, why do you think such important data may be missing? You should comment on that, just like you should answer, why do you think college data might be missing? So I look at that and say, okay, well, if there's anything there at all instead of these two dashes, then the dollar sign is the first component. Python indexing, again, starts at 0. So if I do some array type slicing, like things we've seen, I can say, well, from 1 onwards, then that will give me the number. So it's like 2 2,808,600 is the salary for that first player. So you see that and you go, oh, okay, well now I can split that string, and it's clearly a string. You see the tick marks on either side of it. I can split it according to wherever the commas show up. And when I do that, so I'm running it here. You'll see when I split that salary, then you say, okay, well, it splits it into 3 things here. So I'll just go ahead and run this again. So if I do salaries and if I do the split, there we go. I don't know why it was displaying that. I've just been running things out of order. But there you go. The salary is, it's a length 3, and it has 2, 808, and 600 as the 3 components of the list, and now they're all in strings. And then it's pretty clear how to convert this into dollars, right? I take 600, I add it to 808 times 1,000, and I add it to 2 times 1,000,000, and that will turn it into a float. So this is informing how I can create my convert salaries function. So I'm going to pass it the salaries as a variable S. I'm going to create the salaries in US dollars. I'm going to create that as an empty list initially that I'm going to append values to. For every salary that's in this S list, this S series of data that I'm giving, I'm first going to check if it's actually the string of 2 dashes, right? That's where it was missing salary data that you see right here, for instance, in that 4th component. If that's the case, I'm going to append not a number to my salary in US dollars to that empty list. I'm going to append not a number. Otherwise, I'm going to take the data that is based on splitting the salary according to wherever those commas are. I'm going to create a temporary variable that's 0, and I'm going to loop through for j in the range of the length of that data. Why am I doing this? Well, I don't know. I mean, you can imagine right now the salary, everything's in millions, but maybe you could have a player whose salary is in the hundreds of thousands. And eventually maybe there will be players with salaries in the billions. I don't know, right? Salaries are getting high on some of these professional athletes. And with rampant inflation, who knows where these salaries will go. So I don't know how many commas there might be. So I don't know actually how long this data list is for the individual salary. Maybe there's only 2 components because it's in the hundreds of thousands. Maybe it's in the millions, so there's 3 components. Maybe there's 4 components because it's in the billions. Eventually you're going to have salary maybe on the whole contract size, and we already have contracts that are getting close to $500 million when I'm making this video in 2022. Who knows where they'll be in a few years. So I'm going to go through however big that data list is, and I'm going to start counting backwards because the units of hundreds of dollars is the last component, and then it goes, right, when I look at this, here's the lowest denomination is the last component, and then it's thousands, and then it's millions. So what I'm doing is I'm casting the data as a float, and I'm counting backwards because j will initially be 0, so it'll grab me the last one, and then I'm just using negative indexing to go through that data array in reverse order, and then I'm multiplying it to first 100, 10 raised to the 0 power when j is 0, then I'm multiplying it to 1,000. That's for the units of 1,000, then I'll multiply to 1,000,000 and so on. It goes up every, I want to basically move this data over by units of 3. There's other ways to do this. You could imagine that you just concatenate these all as strings. That's something I'm just kind of thinking of as I'm making this video. I just happened to think of this first, so I did it this way. But you could concatenate all of these strings together and then just cast it. That would be a lot better than doing what I did. So and that's something I highly recommend you try, is take this data, split it, and then just you could just loop through and concatenate all the data together into a temp variable as a string, and then you could append the casting of that temp variable as a float. That would be a good way to do it with concatenation of string variables. I did it this way. You could do it however you like. I leave it up to you, but that's my function. And then I just showed how it worked. I take my salaries as US dollars. I feed in the salaries that I've taken again off of the Nuggets data frame. And I now have the salaries as a list of US dollars. And Now I leave it to you to go ahead and write that inside the actual data frame to change the salaries in that are listed there using this list of data, and then to change the column name as I suggest in the instructions. Again, I'm not doing quite everything for you. I want you to do this, change the name and write this into the data frame, but that's for you to do. Just follow what I did with the Broncos roster data to see those specific steps and adjust them accordingly. Now, the height data, a little trickier. When I look at the height data and I write it as heights, as the variable heights, just to isolate it, we see it's definitely these string objects, and we see it has these tick marks, which makes things a little interesting in how they're stored. So I see like 6'6", I see 6'11". There's these different heights. And you go, oh, okay, well then, how am I going to deal with this? Well, if I look at the first entry of this heights, you see it's a string, and it's going to use this backslash with the tick mark in order to basically, how does it encode a tick mark in a string when strings normally have tick marks around them? It's stored with backslash with the tick mark. So it kind of has this structure. Oh wow, okay, that's what's going on here. And there's also a space. I can see that there's a space between these values. So if I split the height data according to the space, then I'll see, oh, I'll get, this is the interesting thing with strings. A string you can make with either the quotes or a single tick mark. So there's either basically a quote mark from your keyboard, like double quotes, or a single tick mark. So when there's double quotes, then it's going to use a single tick mark to store the string variable. That's what the inches. And when it's feet here, so that they use the single tick mark, then it's storing that as double quotes. When there's a mix of single ticks and double in quotes, then it's going to use the single ticks to describe the whole string variable, and then any single tick that's within the string variable will have a backslash on it. So if that didn't make sense, don't worry about it. It's just there's interesting things that have to happen in order to store the variables and kind of represent what they look like depending on if it's a string, and there's certain reserved characters for how strings are stored. But now that you have this, all right, you can say, all right, if I look at that split variable and I look at now that list and I look at that first component, I see that it's that 6, and it's not showing me that backslash there, which again, like what's going on, but it is stored with the double ticks. We do see that here. It doesn't show it up there. I'm just showing that because I thought it was a little interesting. I had to go through this just to make sense of what the structure of the data was before I could write my own function. But I see that the first component is the number I want, so I can just do array slicing or indexing. And then the thing is, when I look at the second component, it could be 1 or 2 digits. All I know is I want to use all the elements of the string up to, but not including the last component. So if you look at how I convert my heights as a function, the main thing with this function that I want to draw your attention to is after I split according to the space, then I look at that first component of the list and I say I want the first character, because that's going to be the number that I want. So that would give me like the 6 right here, but not that tick mark. I want to cast that as a float, multiply it by 12, and then that's how many inches the feet are, and then there's the leftover amount of inches, whether it's like 6 inches, 10 inches, or whatever, and that's held in the second component of my list, and I want to use the first and up to, but not including the last component. So I do 0, -1, because I don't want to use those double quotes that are stored as the inches. So I know I went over that kind of a little bit fast, but that's what I'm doing here to grab that, and then I cast that as a float, and then I add it. So that's it. I add those two as floats with 1 multiplied by 12. I append it to this list iteratively, and I'll get the heights. And you can see my height in inches, where I can call that function. Everything's been converted to inches. So those are the more complicated functions. The weights, you can just basically strip. There's another thing you can do, split. Another thing you can do is strip. It's up to you. You could just see what it looks like. So maybe I'll just go ahead and show it here in real time. Let's see how I can manage to maybe mess this up. So if I look at the weights data, and let's say I look at weights here, there you go. So you see it's like 220 pounds. If I look at like the first one, you see that it's a string with 220 pounds. And if I do dot, let's say strip, and let's say I put the like the pounds units there, notice it strips that off. It just removes that from the string. But of course there's still that space that's there, so I want to remove that space with the pounds. So then if I do that, it's there, and then I can of course, you know, do something like dot as type int, and then, oh, excuse me, that's a string object, so I shouldn't do that. I can cast it though as an int. So there's 220, or I can cast it as a float, which is I believe what I wanted to do. So you might just want to do a loop, or again, a user-defined function to just kind of do that. I'm showing you just a useful thing. You could also do the separate part. I'm just going to go ahead and delete these for now because I want you to play with it. Of course, you can pause the video. And again, just to reiterate where I leave this video is you need to actually take all these transformations, write them into the data frame, change certain labels of the columns of those data frames, compute some statistics on certain columns. You should do it on the weight, the height, and the salaries, of course. Just do the dot mean on everything if you like, but also show how you can specify certain columns to compute statistics and comment on the results, like what's the average salary, what's the average height, what's the average weight. So make some comments in a, of course, when I mean comment, like add comments in a markdown cell. So that's it. I think I've shown you the more complicated parts of what you need to do coding wise, but also remember to do the parts I'm not showing you, which is again writing into the data frame, doing the missing college data, all that other stuff. So that's it. Thanks for watching, and I think there's one more activity to do right after this, and so actually I will discuss that in the last part of this video. So the second activity is a little less involved than the previous one. We're getting into Nicola Jokic's statistics from ESPN. So I'm asking you to read in his statistics from ESPN. So I provide a link here that takes you right to Nicola Jokic's player profile page, the two-time reigning MVP of the league. And what I'm asking you to do is just check out that webpage, see how many different tables are read into the list, show and discuss what some of these different tables contain. So I want you to read it in. There's going to actually be quite a few. If you look at this, if you kind of scroll on this webpage, there seems to be maybe a table up here. There's this table down here. There's this other regular sheet. Like there's quite a few tables in here in terms of average totals, miscellaneous totals. So there's quite a few tables. There's even some like a table over here in terms of standings for the teams. So there's all sorts of things that are showing up here. So I want you to go ahead and read in that data, and I want you to just discuss what some of these different tables contain. I just want to have you have practice with that, and you're going to get a list of data frames, and you're going to have to look at them and discuss what's going on in these in the different tables. What do each of the data frames contain? I want you to, and you can comment on that in markdown cells that follow the display of each of the contents. I want you to repeat the above steps from here to read in his postseason data. You'll have to search on the webpage for how to access his postseason data. Of course, I'll show that in the solutions. It's pretty straightforward. And then I ask you a question here. What if you tried to get this data from basketballreference.com or NBA.com? So I try it, and I'm not providing the links here. So you're going to have to go find these pages. I'm basically telling you what they are, but go find them and comment on any difficulties you may encounter and try to explain them. In fact, it may not even be possible to read in this data from a web page, even though it might look like there is data available on the page. I want to see if you can figure out why. You don't have to be right. I just want you to think about it and offer what is a plausible explanation to you. And you might search through the errors or whatever information you might find, depending on what kind of output you get, that explain why. So I'll see what I decide to discuss in the solution part of the video, which is coming up next. All right, so some partial solutions for activity 2. So this URL is just taken from me copying and pasting what the content was for ESPN's URL involving this player statistics for Nicola Jokic. And then when I use the read HTML in and I create the list of data frames called Joker, that's his nickname, and I look at the length of that, I see that 7 data frames are read in. 7 seems like a lot. When you look at this, you say like, well, maybe there's this one, but is that even read in? There's these, what looks like 3 tables. There's this thing over here. What's going on? Where are all these tables coming from? Well, if you look at this, if you look at what some of these are, it's actually splitting some of the tables into 2, even though they appear like 1. So like if I look at the first entry, you say, oh, it has all this data here, it just has these. Where is that coming from? That's this part right here, see this kind of vertical line, like it's actually reading this these two columns here. And even when you go to highlight, you can kind of see like, oh, it's just grabbing those two by themselves, right? And you can kind of see it the way you would even grab, like like if you were to just try to select things, you can select this stuff separately from these columns. So this is a separate table over here on the left than what's going on the right. And it's not readily apparent. You wouldn't necessarily think that's the case when you first look at it, but that's how it's read in. And so you might even want to combine tables. How do you do that in Pandas? You can look that up. How do you combine data frames together that have the same number of rows? You can see things like the last one involves the career. There's no team associated with that because a player might play for many teams over their career. So the individual team can show up in any given year. Players can be traded in the middle of the year. So then you can even have multiple rows associated with the same season. So you can imagine cleaning the data. Like if you wanted to figure out what the averages were when in a season, maybe a player gets traded a couple times. Certainly Jokic should never get traded from the Nuggets. But some players, lesser quality than Joker, might get traded, and then the data structure again can be complicated. You'd have to write functions to try to clean that data, look for the same season but multiple rows, combine it into a row, like figure out how to average them because it's a weighted average. They might play different numbers of games for the different teams. So figuring out how to combine all that stuff, this is where data cleaning, data wrangling, like these are things you have to confront again when you deal with real data. It's messy, and it's not necessarily in the format you expect. So anyway, when I look at that second data frame, here's his regular season averages, and then you have the total averages in that last column. Again, that's for his career. I'm not going through all of them. You should go through them and kind of explain what's going on there, and maybe think about issues you might have with other players, or just dealing with statistics and how you might even think about these types of data like field goals. If you think about that, you see 3.8-7.5. What's going on there? In his rookie year, he was making on average 3.8 out of 7.5 attempts, shot attempts per game. His 3-point attempts are similar interpretation with that hyphen. So again, if you wanted to try to convert this data or check did these percentages get computed correctly, you would have to do some analysis on this, which is clearly going to be in a string variable that you'd have to split around a hyphen and do some initial, like maybe you want to create things to say, I want to look at field goals made versus field goal attempts. So maybe you want to take this feature and add two new columns to the other side of it that are field goals made, field goals attempted, and then you'd have to split the data across that hyphen and then separate it out into two different columns. And then maybe you also do it with 3-point field goals made versus 3-point field goals attempted, free throws attempted, free throws made. So you can imagine that there's a lot of little changes, little things you'd have to do just to get the data in a format that you might prefer. So again, just trying to show you like real data and how messy and kind of strange formatting that it might be, even though if it doesn't necessarily look strange, the things you have to deal with in order to start computing your own statistics, because maybe these percentages right there maybe not computed already for us. So I just want you to go through again, figure all this stuff out, like what's in there, just think about it, add comments. It's a really good exercise in just kind of the messiness of general data. And then I also wanted you to repeat the above just to see how to read in the postseason data. If you look here on this button here, if you go to postseason, you'll see the season type 3 has changed, and that's what's going on here. You need a new URL. There's a different number of rows. Why is that? Well, the Nuggets don't go to the playoffs every year. Certainly not in the first few years when Jokic was younger. Now they're a regular mainstay of the playoffs. They're one of the better teams in the NBA. So you should, again, take the URL, read it in, look at all the tables, explain the data, kind of issues and what's going on with the data. The last instruction, what if you tried to get this from like the basketballreference.com or NBA.com? And comment any difficulties. So I show like from the Basketball Reference, I just went to the web page. You can search for it and you can find Nicola Jokic's URL. You can read it in. There's 6 data frames that are read in there. Here we see that the season, his age, the team, and I guess whether or not he played in the NBA or some other league, because maybe he played in there's players that are maybe in other, like there's the G League, there's other leagues other than the NBA. So maybe they're taking like European leagues into account now, but they're keeping track of data, and it's all in a different table here. there's something else that's going on right here. Notice they have field goals and field goals attempted, and then I think they're going to have field goal percentage. You can, I think, change this into an interactive. Yeah, so field goals attempted. So this would be field goals made. So that would be like if you wanted to transform the ESPN data into this data, you'd have some work to do, or you could go find basketball reference data and it already did the work for you. So again, it works fine with basketball reference. It's in a slightly different format though than what we saw with ESPN's. And you can go see that for yourself. Go look at the data on that webpage. When I go to the NBA.com and I look at his player data, so here's Joker, and I look at this, I say, oh, there's data here, right? There's clearly these tables, and there's lots of, in fact, data that's here. There's interesting, more advanced statistics too. Advanced data like assist to turnover ratios, all sorts of things. But when I try to read that in, I get that there's no tables found. It's a value error. And you could look at this and say, what do you mean there's no tables? There's plenty of tables. I see lots of tables here. But one thing you might notice is when, like, I'm on ESPN's, if I just hover my cursor anywhere on here, nothing's really changing, right? Like, look at this. Look at my cursor, right? You don't notice anything. Like, I can just select like these individual values, but these things aren't highlighted. Here, there's clearly something going on. When I move my cursor around, there's something else happening on this table. So there's some sort of like maybe JavaScript. There's things that are happening that are kind of making it impossible for Pandas to read in this data. This data isn't really it's not exactly encoded in a way on the web page in the HTML of the page for me to be able to scrape it in using read HTML. It's somehow like embedded in a script that has some interactivity in it so that I can hover my cursor and highlight individual rows. And this is problematic for Pandas read HTML. It just can't read it in. And so you could go look at what do you think the specific issues are with this? But it's just something you should be aware of. It's just because you see the data, you might not be able to get it. And then you have to think maybe what do you do? How would you perhaps get this? You might have to do some more advanced web scraping, use something besides Pandas that can handle this type of data presentation, or just try your luck trying to find that type of data present in a different format that's more amenable to reading it in HTML. But I want to show you, like, you can't just use this everywhere. It's not always going to work. And you have to be aware of some limitations of these code packages, and then that may mean you have to go use something else to do it. So that's it. I didn't, say a lot. Most of this exercise was about, this activity was about you going through this, printing out a lot of this data, thinking about it, commenting on what these tables contain, and just, adding maybe some of this commentary about how you manipulate the data. I just want you to really think about the messiness of the data and how you might have to clean it or change the format in order for you to do the types of analysis that you might want to do. Because maybe you're not interested in sports, but you can certainly imagine if you're collecting data on any kind of like biological species or human beings, patient data, consumer data, you're going to have all sorts of different categories, and some of them might be very categorical. But you could, in terms of like the values, some of them could be numerical, but just because they look numerical doesn't mean, like, these look numerical, but it doesn't mean they're in a numerical format. And you're going to confront or have to confront the issues of working with real data, whether it's missing data, the data's in the wrong format, there's some sort of weird presentation of it, there's the units are not the units you want to use, you need to convert them. And it's going to cause you to have to write user-defined functions, change the data, change it in the data frame, and then eventually you probably say, once I have gone through all that work, I'd like to save my results. And that leads us really to the last part of this lecture notebook, which is about reading and writing the data to file. Before we do that, we have this brief kind of transition, which is kind of related also to this issue that we saw about data. So it is not unusual to find data sets from websites available to download as spreadsheets in various formats. So this also happens. That could be like comma separated values like CSV files or Excel type spreadsheets. The next part of this lecture notebook discusses how we may be able to read and write data to files directly if you were to download such files first and then upload them to Colab, or just read the files directly in from some website and into Colab directly, into a Jupyter notebook. So an alternative, which I'll show below, is sometimes available that allows us to simply load the files directly into Colab. Of course, you may still want to write the data to file, in which case the steps shown in part B of this lecture are still necessary. So this just helps us save some time and steps. So I'm going to just stop here. This is related to this last issue of just sometimes the data isn't available in the format that you can maybe read it in directly. We're going to readdress that at the start of the next video, but it is connected to where this kind of activity leads off and where the final part of this notebook goes in terms of reading, writing data to file. So it's all connected, and we're kind of motivated now to understand once we go through all this effort and transform the data, we want to write things to file, and maybe we also want to read data in directly from files instead of from websites, or want to read it in from files that are loaded on, that are available on websites. So that's what we're going to talk about in the next video in the last part of this lecture notebook.